So for the final aspect of my presentation, I looked at um, different arcs on shots and why a greater arc yields a greater chance for the ball to go in. Oftentimes when I'm playing, a coach will tell me if I'm not shooting well, a coach will say my shot's a little flat, or they recommend arch the ball a little more. And if you look at Dirk's shot, he shoots with great arc. Dirk and Derek Fisher, the two players in the NBA, who have the greatest arc on their shot, and they're both consistently in the top 10 in the league in shooting percentage. So I don't think it's any surprise that arc um, increases a person's chance of making a jump shot. But the purpose of this experiment is to figure out why um, a greater arc yields a better chance for the ball to go in. So to test this, once again we're going back to our three clips: clip 14, 16, and 17. We're going to start with 17. So clip 17 is me shooting a very flat shot. So we'll take a look at that. All right, now let's try and slow it down and break it down piece by piece. Okay. So when the ball releases from my hand, right, so here's the path of the ball if you can see my mouse. Now let's say this is the horizontal. The angle of release, let's say, is approximately 20 degrees. Let's say that the release angle is 20 degrees for my flat shot. Now let's look at an intermediate shot. Slightly greater arc. Let's pull it back and look at my release angle. Now, ball out of my hands right here. Here's the path of the ball, right? Let's say this is the horizontal. I would call this angle approximately 30 degrees. Now let's go to clip 14, which is max arc in my test. Let's look at this. Alright. And let's follow the path. Ball out of my hand right there. Now, if this is the horizontal, the ball is following this pattern. I would call this between a 40 and a 45 degree angle. Alright. Now, I analyzed each clip in LoggerPro, and what I did is I took screenshots of each graph. So let's look at screenshot for clip 17, the flat shot. What I noticed, here's 17, here's shot 16, and here's shot 14, which is max arc. Okay. Starting with clip 17, what I noticed is that the slopes for the x-coordinates, so the average velocity for the x-coordinates, were much higher when the ball was shot at a flat angle as compared to a greater angle. So for clip 17, we determined that the angle of release was approximately 20 degrees. And if we look at the slope of the x-coordinate, the linear fit here, our slope is negative 4.403 meters per second. So our average x velocity is negative 4.403 meters per second. Now let's look at shot 16, the intermediate angle. We assumed it's approximately 30 degrees. We look at the slope, and the slope is now negative 3.769 meters per second. So the average x velocity has decreases when the angle increases. And now let's look at shot 14, max. Sorry, wrong clip. Looking at max angle here. We assume it's approximately 45 degrees. We look at our slope. Our slope is negative 3.152 meters per second. So our average x velocity is negative 3.152 meters per second for the greatest angle in my test. So as the angle increases, according to these screenshots and according to our data, As the angle of release increases, the average x velocity decreases. So what this leads me to believe, and in terms of the reason why more arc is yields a better opportunity for the ball to go in, is because when I'm shooting and when any basketball player shoots, the muscle memory, your body is applying the same amount of force to the ball, no matter at what angle you shoot. The force is constant. So if the force is constant, when the ball is released, it's gonna have the same amount of force acting on it no matter which angle it's released. So at a flatter angle, the flatter the angle is, the greater the x velocity will be. Therefore, the faster the ball is moving horizontally through the air. So when a basketball hoop is the width of the width of a basketball hoop allows for 2 basketballs to fit through it at any time. The faster a ball is moving horizontally, the less chance it has to go in the hoop. Subsequently, the slower the ball is going, the more chance it has to go in the hoop, or the more chance for error. The shooter can be off, one way or the other, and still allow for the ball to go in because the ball is within the radius of the hoop, is within the circumference, is within the area of the hoop for a greater period of time. And this is what I've come to find as the reason for why greater arc yields a better chance for the ball to go in, or a wider margin of error.